For your notes, the essential question is, how does the force and mass of an object affect its acceleration? There are 4 guiding questions to answer throughout taking the notes and watching the videos that you watched today. And then at the end of your notes, you will answer this essential question. First, if we're going to talk about acceleration, we need to make sure that we understand what acceleration is. Acceleration is the rate at which velocity changes. Now, here's a word we actually haven't talked about yet in our class, and the word is velocity. Velocity is an object's speed and direction. So we could say that if an object is traveling 50 miles an hour north, then we have described the object's speed. Now, if one of these things changes, either the speed of the object changes, or the direction changes, or both, then we say that this object has accelerated. Most people think that acceleration is when an object speeds up. Well, that's part of it. Acceleration could be an object speeding up, it could be an object slowing down, or it could be an object changing direction, because acceleration is the rate at which velocity changes, and velocity is speed and direction. Therefore, if an object changes one of these things by speeding up or slowing down or changing direction, we say that the object has accelerated. Now, acceleration can get a little bit complicated because acceleration is the rate at which the speed of an object changes over the amount of time that it is traveling or changing this speed or direction. So one example of an object accelerating is when an object is falling. When an object falls because of gravity, it is accelerating each second that it falls. The acceleration rate of gravity is 10 meters per second for every second that it falls. To be exact, it's 9.8 meters per second every second it falls, but for just keeping things simple, we're going to round to that speed being 10 meters per second. This means that if an object drops, and gravity is the only thing acting on it, if it drops for 5 seconds, it will continue speeding up every second that it falls. Notice that this object that is falling off of this cliff is here at 1 second, here at 2 seconds. It's covering more distance because it's speeding up when it reaches 3 seconds, covering more distance at 4 seconds, and even more distance at 5 seconds, which means that it is accelerating as it is falling. It is increasing its speed for every second it falls. Now, this is important to understand because the unit for acceleration is meters per second, or some people would say meters per second squared. What this is describing is the speed of the object, or the change of the speed of the object, per every second that it is actually moving. Acceleration is the reason why an object would be traveling at a faster speed at the bottom of a ramp versus the top of the ramp, because it's falling longer. It has more of a chance to fall at the bottom of the ramp, showing once again that acceleration is the change in speed considering the amount of time that it is changing speed. The unit for acceleration is meters per second squared. Now that you understand acceleration, we can talk about Newton's second law. Let's consider these 2 objects. You have an object with a larger mass because it's full of stuff versus an object with a smaller mass. Newton said that an object will increase its acceleration if you have increased force. Coming back to this, we're going to hold on this example for just a second, considering the 2 different masses, and we're going to consider an object that has different amounts of force acting on it. So let's consider that you have the same mass objects, but you have different forces acting on them. This man is putting a larger force on the shopping cart than this boy. Therefore, he will have a greater acceleration because he has a greater force. Newton said that acceleration increases when there is increased force. But And going back to the first shopping cart example, he said that acceleration will decrease when there's increased mass. So here's that example again. This time we have the same amount of force placed on two different shopping carts with different masses. The object with the larger mass will go slower than the object with less mass. The object with less mass will have a greater acceleration, and the object with more mass will have a smaller acceleration. Newton said that acceleration decreases with increased mass. So once again, Newton's second law states that acceleration increases with increased force, but acceleration decreases with increased mass. This is why, on a football team, the bigger guys are usually on the line and not the running backs, because the bigger guys usually just go slower than the guys that are not as big. Newton discovered that there was a way to calculate the amount of force on an object if you could consider the mass and the acceleration of it. He said that the force on an object is equal to the mass times the acceleration on an object. Remembering that the unit for force is newtons, the unit for acceleration is meters per second squared, and the unit for mass is kilograms or grams if it's a small object. Let's put this into practice. Let's say that you have a bowling ball that has a mass of 6 kilograms and it leaves your hand at an acceleration rate of 60 meters per second squared. That means that for every second that it's traveling, it is increasing its speed. How much force did you put on the ball? Well, using the mathematical formula, force equals mass times acceleration, or F equals ma, we would take the mass times the acceleration, 60 meters per second squared, and therefore we would calculate the force on the object. I'm going to let you calculate the force on the ball, and remember that your unit is newtons.